The question says, which of the following reactions is not fixable? What this simply means, which of the following reactions will not occur? Okay, first thing I want you to consider is that in terms of reactivities of elements, I want to make use of group 7 elements as a case study because majorly we have chlorine, fluorine, chlorine, bromine, iodine. They are all group 7 elements. In group 7 elements, fluorine is more reactive element. Is the most, let me just say, it's more reactive than chlorine. Among the electronegativity elements, fluorine is the most reactive element. So fluorine is more reactive than chlorine. Chlorine is more reactive than bromine. Why bromine is more reactive than what? Than iodine. That is, fluorine comes first. It has access to send chlorine away because it's more powerful than chlorine and it's more reactive than chlorine. So chlorine likewise have access to send anywhere to come across bromine because chlorine is more powerful than bromine and fluorine is more powerful than bromine too. This is more powerful than this. If this is more powerful than this, simply means that this also will be more powerful than this. So likewise, bromine is more powerful than iodine. Anywhere bromine come across iodine, it has access to send away iodine. So, but among them all, this is the most powerful, followed by this, followed by this, followed by this. Anywhere, if iodine come across bromine, iodine cannot send bromine away because bromine is more powerful. It's just like you saying, okay, a boy of 2 years to send an elderly person of 20 years old. Can that be possible? No, it's not possible because someone that is 20 years old is more powerful than a boy of 2 years old. So this cannot send this one away. This have access to send this away. So chlorine cannot send chlorine cannot send fluorine away, but fluorine have access to send away chlorine. Okay, so coming back to our questions, if you should look at it clearly, you see that yes, fluorine have access to send away this chlorine to take the position of this chlorine. When this fluorine send away chlorine, it will take the position of this chlorine, which becomes sodium what? Fluoride. Which is this? It has displaced chlorine away. So this reaction can occur. This reaction can occur. Now let's look at this. Chlorine reacting with sodium iodide. Yeah, chlorine have access to send away iodine. As I've said, chlorine is more powerful than bromine, it's more powerful than iodine. So it have access to send iodine anywhere it come across iodine. So this reaction will occur when this chlorine replace this iodine, it's displacing iodine away. That is this. This reaction can also occur. Okay, let's look at option D before I come to option C. Option D, bromine and iodine. You know, as I've explained earlier, that bromine can displace iodine away. It's more powerful than iodine. So this reaction can occur in the sense that if bromine now take the position of this iodine, it becomes chlorine, it becomes potassium bromide, which is equals to this. Now it will now send this iodine, displace this iodine away, which is this. So we can say this reaction too occurred. But let's look at this reaction. Chlorine reacting with potassium fluoride. Okay, can that be possible? Can chlorine send fluorine away? Is it possible? Look at fluorine. Can this chlorine send away this fluorine? Based on the explanation I've explained earlier, we notice that it's impracticable for chlorine to send away fluorine. So fluorine is more powerful than chlorine. So this reaction cannot occur. This reaction cannot occur. So our correct answer is what? Option C. Option C is our correct answer. Okay, stay tuned for more tutorial videos. Do well to subscribe, like, comment, share. Thank you.